This video was sponsored by xTool. Yeah, over the past 10 months I've been uploading weekly build videos onto YouTube, and it's super interesting how much stuff has changed over that time span. I was doing it out of somewhat of a frustration because I had a lot of YouTube channels which kind of failed before that. And so I was just like, you know what, I'm done. I'm just going to make videos about whatever I want to make videos about. And I don't care anymore. I'm just going to build stuff and I'm going to film that stuff and I'm going to upload that to YouTube. And all of a sudden, stuff started to go really quite nasty. And it dawned on me how much my process has changed over those 10 months, because I went from using very rudimentary like hand tools like jigsaws, circular saws, drill press, and just gluing everything together. And that was quite fun, but now my process has completely evolved into a very digital, high-tech workflow. And I hadn't noticed that. Now, what is this dude actually doing? He's waving this laser thing in the air, and all of a sudden that ends up in a CAD program, able to cut through a solid piece of wood with what is essentially light. And then we have these strange plastic printing machines. Like, it's delusional. You know, you forget about it after a certain period of time, maybe even like a day, you know? And this video was sponsored by xTool. They sent out the S1, which is a really awesome laser cutter. And after receiving that, you know, I just put it on the desk and I nearly just forgot about it. Like, it was super normal to me to have that thing there, and, you know, I could wrap my head a little bit around it. It's just focused light, like, you know, and it's on the gantry system. But the amount of hours that had to be pumped into that machine, the amount of innovation that had happened to make that machine actually function in the way that it functions right now is super impressive. And we take our tools for granted quite a lot these days. And so in this video, we're going into a little bit more depth of the tools that I've found, which are just super awesome and which I utilize the most on the channel as well, are very easy. And we're going to go into a little bit more of the software side of things, so that you can also see like how does it get a 3D scan into the CAD software and then convert that into a nice model to laser cut on something, and then also implement 3D printing. So one of the most awesome devices that I've ever bought for the project on the channel is this 3D scanner. This is the CS-Scan Raptor, and it basically allows us to convert, you know, real-world physical objects into digital versions of them that we can import into the CAD software. And it's one-to-one, so, you know, pretty accurate 3D scans that we can utilize to 3D model something. In this case, we're going to use this rare ratcheting screwdriver and 3D scan that. Now, of course, we do need some additional things to actually get this to work. So I have a turntable over here. I built that in one of my videos if you want to check it out. Sometimes if you order one, then it comes with a turntable. But you also need these little markers. They have reflective stickers on there, and this helps it scan a little bit better. So you don't necessarily need a turntable if you're using the infrared mode on this thing. And the infrared mode is pretty awesome because it just keeps track of the object by its geometry and that kind of stuff. But it's not that great if you want to quickly do something, as it loses track quite often and it's kind of a pain to use. So I'll be focusing on the, you know, laser scanning with this device. Right, so as soon as we have the software open over here, we can see which scanner is connected, which project we've done in the past over on the left-hand side. And up top over there, we can click on scan as the scanner is connected. So we can give the project a name and choose which scanning mode we want to be in. So infrared or blue laser mode. We're going to be focusing on blue laser because we have the turntable set up. But we can also go into infrared mode if we have like a large suitcase that we want to scan. And then we get a lot more options. I've had the most success with texture instead of the geometry version. I haven't tried marker yet, but that might also be quite interesting. So we're just going to keep it in blue laser over here. We can see that, you know, as soon as we point the 3D scanner at the pucks over here, they all show up. But we're not actually scanning yet. So we either hit the button on the top over there, or we can do that via the software. You know, just hit the start button over there. And I'm going to do it on the top over here. And it immediately starts capturing the data that we need. Now, if you'd like to pause the scanning mid-scan, then you can do that as well. You just hit the button again, and that just stops it for a little bit. Yeah, you can open the door for the postman or something like that, but then you can also press the button again and it will immediately pick up where it left off. So once the scan is complete, we can see that there's a bunch of extra data that we've collected, right? These things in, mid-air, those might actually be reflections that I didn't quite understand what they were. And we need to clean the scan up a little bit. So we hit complete scan over here. Hit yes. It's going to process it a little bit. And before we do anything, before we process it, or before we hit one-click processing, we want to get rid of as much data as possible. So we're going to hold shift on the keyboard, and we can select the data that we no longer need. Like that. And then hit backspace to get rid of it. So shift, select it, this little tool, hit backspace. And let's clean it up as much as possible to the point where the only thing that's left here is the thing that we actually want. Then we can hit processing. Now, usually I just, hit auto and let the program do it. That's mainly because I don't have a specific goal other than getting the dimensions. But if you're doing this for gaming or like creating a game, for example, you need to mess around with the settings to get the most optimal use case out of it. So as you can see, we just finished the processing and it's turned out really quite nice, but we're missing some details at the bottom over here. If we want to capture those details, we can, and then we can combine two scans into one, which might be a fun showcase. So let's do that. That we have a layer and we can just hit the plus one over there. And it takes us to a new scan page and we can just select if we want infrared or blue light. Again, we'll keep it on the same settings as the first one. I'm going to use a piece of clay over here to, hold this thing up a little bit better. I'm just going to put that in the middle and press this into it because we already have this side scanned pretty nicely. We don't need all of that data. We just need the top section over here. Hit the scan button. Try sideways, see which, how the reflections react and that kind of stuff. So this one's definitely a little rough. You can see some artifacting on the side over here, which might be because I went past it a few too many times, but it did capture all of the data over there. And what you can see is as soon as we processed it, in the corner we can see point clouds merging appear, which is an option we can select. So we'll go into that and both our scans will appear in this thing. If we select both of them, we can, choose auto merging or manual merging. We'll see if auto merging works. So that went pretty okay. But if that doesn't work, then you can also choose manual merging, and then you'll have to select 2 points to get it to do that. But that's for a different video. So let's just select yes. Now once the processing is finished for both the mesh and, simple processing, we can hit the export button. And if we didn't do the mesh situation, we couldn't export it as an STL. But I like to export it as an STL. There are two other options available though, that's PLY and OBJ. I suppose that if you're using Unity or something like that, you'd export as an OBJ, but we're importing it into Shapr3D, so we're going to export it as an STL and give it a name. So it's worth mentioning you can 3D scan the object itself, but you could also 3D scan a piece of plasticine that you've molded into, for example, the shape of your hand to get an ergonomic sense for, how you're going to be modeling it out in CAD, because that gives a real nice solid indication of like where do you need to place material, especially if we're going to be moving on to the 3D printing or laser cutting. Then we know how it's going to feel once we have it in our hands. So I think that's already a great showcase of how powerful that tool actually is, getting those measurements, into the CAD software really quite quickly. It takes like 5 minutes to scan something. Most people don't realize that that trickles down into the process as well, right? Prior to actually having this 3D scanner, I used to use a caliper to do all of the projects, and that works out fine, but it takes quite a long time to actually measure everything up and get that into the CAD software, double check it, but then even more time because you have to pre-check it, right? You're doing a test print, and if that test print doesn't fit, you've just wasted 2 hours, and you do another test print until it's completely, accurate. With this 3D scanner, I've managed to get it to a point where I'm no longer doing test prints. I just sent a 3D scan to my iPad via the airdrop function, and I've opened Shapr3D. That's the CAD drawing software I use on the iPad. As you can see, I already messed around with it over there, but what we can do is hit the plus icon at the top over there, which starts a new project. Hit the 3 dots, hit import, go to files, we can see the 3D scan appear over there. And then once we import it, it's going to ask like, do you want to import it in centimeters, millimeters, meters? We want to keep it on millimeters over here. Hit done. And it's imported the 3D scan into the world, as we can call it. And you can see it appear in the layer panel up here as well. So if we open this layer, then we can see that there's one mesh over there. But if it wasn't too good of a scan, there might be multiple meshes in this folder, and yeah, go ahead and delete some. But it's not really straight, as in it doesn't line up with, you know, the entire world as we have it here. So I select it and then I try to match it up as nicely as possible. So after we have it all lined up in the grid over here, so you know this side lines up nicely with the blue line, go over here, and this one of course also lines up nicely with the blue line, and the top looks half decent, then we can actually start the modeling process. And I'll walk you through the program as it is right now so that you get a better sense for how this actually works. On the side over here we have a little mini map, I'm going to call it, so you can select front, top, and you know, even in between if you want to do that. And up top here we can basically switch between two modes. So you click that, you can switch between modeling or visualization. If you go into viz, then we can give stuff textures, which is really quite nice if you want to export as a picture for your, you know, Patreon page. So yeah, if you're enjoying the video so far, then definitely also consider checking out my Patreon page. Subscribing to the channel is a free way to support me. Liking the video, leaving a comment is also a free way to support me. And if you have questions, then definitely also let me know in the comments, because I'm not sure if I'm explaining the right things. Like, I sometimes watch tutorial videos and I just wanted to know that one simple little thing, and they skip that and it's super annoying. But if you've been doing this for a little while, then you kind of forget, like, what do people want to know, you know? So if you could leave me a comment in the comment section, then I know what to improve upon in the next video. And in the visualization mode, you can't really draw anything. So keep in mind that if you're modeling out stuff, then you want to be in the modeling mode down here. Now, as I showed you just a moment ago, we also have a layer panel that's right underneath that. At the moment, we just have one layer, but we can hide that with the little icon over there, or make it re-enable and reappear. Right underneath that, we have a few settings. If we click this little line, then we go into all the stuff that we need to create like a sketch layer. And basically the way that this CAD program works, and most other CAD programs work, I believe, is first you create a 2D sketch and then you extrude that into a three-dimensional object. So let's say I grab a circle over here and go into the top view and create a circle that's roughly the same diameter as this ratcheting screwdriver. Deselect it, make another circle. Now we're going to go into three-dimensional mode by just, like, you know, dragging your finger upwards, and this turns bright blue, and we can select either this one or this one. I'm going to select the outer layer, and it gives you an arrow, so we can just extrude that upwards. As you can see, we immediately get material in this space. Now, if you want to modify this edge, so to say, you just click the edge, you give it a chamfer or a round over. That's a really powerful tool. Or if you would like to subtract something from this, you can double tap this layer and then add a sketch layer to this, go into three-dimensional mode and subtract something. So you can see that this is super intuitive to work with, and is really fast in terms of, like, okay, you have an idea, just model it out super quickly. And when you download it for the first time, you actually get a tutorial from the program itself, from the makers of the program. Once you follow that, I've personally only watched 1 or 2 tutorials after that on YouTube about this thing, and then I was just off to the races. I was just, like, making stuff. So yeah, I don't think I'll go into too much more details on that, but I am going to show you how I utilize Shapr3D to create these combo projects between 3D printing and laser cutting stuff. Usually you'd use probably a different program to draw stuff out for the laser cutter. I actually do that in Shapr3D because it's capable of it, and it's really nice that if you have a 3D print, you can immediately complement that, right? But the design that I came up with for this one is pretty rudimentary, just a, you know, an example for this project essentially. I want to create a tiny little toolkit with this ratchet in there in a really nice way where I can grab it from a larger project panel that I'm busy with, and it has a couple bits in there. So if there's something around the house that needs fixing, you know, I have the bits with me, and the Vero ratchet is in there as well. But it's still accessible if it's in the project panel itself. So the way that I want to keep the Vero ratchet in place is with a 3D printed component over here. But this main body, I'd like that to be made out of wood. So how are we going to do that? Because it's a much too large a piece to actually, you know, laser cut it in a single go. And if we have 12mm thick layers of multiplex, what we can do is create a sketch layer, which is 12mm. So we end up with a grid like this. And I'll be selecting every second layer like so. So these will be the sheets of wood essentially, right? Then we can subtract that. It turns it into the sheets of wood that we need to be cutting out. We can do that again, but we'll hide this one or like move it someplace else. But this time around, I'll be selecting the other ones, right? So instead of selecting this one, I'm going to be selecting this one, and so on. So something like that. Subtract. And as you can see, we can shove those two pieces in at each other. Input this 3D printed piece somewhere. That'll work out quite nicely. So the only thing we really need to do now is convert all of these little panels into a sketch layer that we can actually use. But that doesn't really account for like how we're actually going to connect everything, because if there's no method for keeping them straight, then it's going to be really difficult to do the glue up process, right? It's going to be all crooked and whatnot. What we can do is basically add some rods down the middle over here. Now, obviously, at this point, you want to like combine them and then subtract for the rods, but I guess I was a little sleepy or something. So 4 mil. I have some 4 mil rods laying around. But then for actually converting this into a sketch layer, this is something where Shapr3D isn't actually, you know, a perfect tool for doing this, but because I modeled the 3D print in this tool as well in the software, it's really useful to be able to create a sketch layer in the software as well. Basically, I moved one of these plates upwards a little bit. I'm going to hit the top layer because it's a two-dimensional thing. We need an SVG file, and we're going to use the pen tool to sketch everything out. So essentially, the way that we're creating this SVG file is by exporting the sketch layer, right? Not the actual object that we've created. And yeah, Shapr3D isn't really optimized to do this. So you need to make sure that you're making the sketch layer in a new layer. And it's not a sketch layer with another sketch layer attached to it, because that's going to be a total pain to fix that. And when that sketch layer is created, we hide everything else. Ideally, you know, most of the layers will be exactly the same as this one, and only 2 or 3 variations, because otherwise you're going to have to do that again and again. So it would be really nice if there was a tool that just did that automatically. And the only one that we want to keep active is that top sketch layer, this one that we just made. So we hit the 3 dots up there, export to, and then export again. Then you can select from this list of files how you want to export it. And in this case, we want to select SVG. Now, it's going to ask you a couple of questions, like what's the DPI, what's the resolution, and you need to give it a name, of course. It depends on which software you use to, you know, operate the laser cutter, what DPI is set at. So mine is set at 96. That won't work on the xTool S1. The xTool S1 needs a DPI of 72 to be 1-to-1, right, with the thing that we have in the CAD over here. So just to explain that a little bit better, when I first started laser cutting, I was super frustrated because I couldn't get a 1-to-1, you know, cutout of the thing that I wanted to create, as I didn't quite understand that the DPI had impact on how big the file would actually turn out in the laser cutting software. And I also didn't understand that different laser cutting softwares, you know, worked on different resolutions somehow, or different DPIs. So I don't know all of the details behind it, but I know that I tried Laser GRBL before this, and I just couldn't get that to work because it has a very strange DPI setting of like 74 point something, you know, something like that. And that's impossible. So the software, like the xTool software, you need to input a resolution of 72 DPI. If you're using Lightburn, which I use for other laser cutters, you need to set it to 96 DPI, and then it will be 1-to-1. And the nice thing about the xTool S1 is it comes with its own application that's on the iPad as well. So, you know, this would essentially be the slicer if you'd think of in terms of 3D print terms. But you can open it up, you can click Add New Project and create a new project over here. And then it opens up your area where you can cut, essentially. Up here, you can connect to your xTool S1. Usually, it's already pre-connected straight away. So it's a really reliable and stable application. And I'll just walk you through a couple settings. You could also just use this to, you know, add some text and engrave stuff if you really want to. As you can see, I've never really used this because I have no idea how this actually works. Now once we have our file here, we can go next to done, hit that button, and then import that into xTool Creative Space. Drag it wherever you want it, and when you have it selected, you'll see that we can, input our settings. In this case, it's set to score, and that has to do with the predefined material. So if we go to processing and we go to user defined material over there, we can select a couple presets that xTool has already put in this machine. So if you have 3mm thick cherry wood, then you can select that, and I'll have some, speed and power output of the machine will be adjusted to that. In this case, I'm just going to use it, leave it at user defined, because I'd like to input the settings myself for this one. But we do have to input those. So, click on the thing again, and then we go to the easy set panel. And this is where we can choose the power. So, whoops. How much is the laser head going to be outputting, and the speed in millimeters per second. For this one, we're going to go for 4mm per second because I do believe that would work, and 3 passes. Now this part is kind of strange because I'm just guesstimating the settings right over here based on the stuff that worked in the past, right? If you had time, just figure out how stuff works, because I'm ending up with a bunch of charred wood, and honestly that kind of fits the project itself, but I haven't had time to actually figure out the most optimal settings. And if you're busy with that all of the time, then sometimes you can't do interesting conceptual things. So you have to kind of make a choice between knowing your machine and how to force your machine to do certain things. Next, we need to, focus the laser head. And the way we're going to do that is you see this distance measure here. And if we click that little measuring button, then it's automatically going to poke its little stick into the wood and return with a measurement, which is really awesome. That's a lot less hassle than some other laser cutters. But once you're kind of satisfied with where it's going to be cutting and at what speed and what power, we can click process and then start, and then it's just going to send that off to the machine once we hit OK here. Now it's not going to start straight away. You need to go to the machine and press the button at the front, which is a safety feature, so don't set fire to anything. And all of these really smart features are probably the main selling point for why you'd go for an xTool machine other than, some other laser cutter. The software is just really intuitive and it's included with the machine, right? So with other laser cutters, you'd have to buy the software like Lightburn separately. That's an additional cost on top of that machine. Here it's just, it's in here and it's super smart. You just press a button and it measures everything automatically. There's not a whole lot that can go wrong when you're operating one of these. But then there's also the expandability. So xTool also sent me the riser base and the conveyor system. I haven't been able to use it for a project just yet because it offers quite a lot of really awesome possibilities, but it does limit the stuff that you can do. So you can only do one pass, right? And if you're cutting really thick wood, which I'm mostly doing most of the time, then you need multiple passes. So for engraving stuff and, that kind of thing, this is really quite awesome. I was expecting this to be super difficult, and that's why it took me quite a while to get this video out. But I just attached that conveyor system, plugged it in, and it just worked straight away. It was so intuitive, it's so simple to operate it. You can see that the engraving turned out really quite nicely. There's no skipping or anything like that, and it's really super straight. So, that's the number one concern I had with this conveyor system, is if you feed a piece of wood through that, how's it going to keep that straight? And there is some more chance in something going wrong with this situation, but so far it's been operating really quite nicely, although we're not doing that project with this conveyor system. So it's quite easy to take off, you just unbolt a couple bolts and unplug the cable. And I actually prefer the xTool S1 with the riser base, but then nothing else attached. This allows you to cut larger things, but in the same very compact format that the xTool S1 comes in. Of course, you do need to wear safety glasses at that point, but that's the way I like to use this machine the most. Now in this case, we're using some material that I had left over, which actually fit inside of the machine, so we didn't have to leave the whole thing open. And that also helps with the air purification system, right? So they also sent me the air purification system, which is a really awesome box of sorts, and it looks like a computer. It has a bunch of filters in there, you saw it in the beginning of the video as well. And it does a really great job at filtering the air while you're cutting materials like wood or maybe even plexiglass and that kind of thing. So I have an air quality monitor which measures for PM 2.5, PM 1.0, PM 10, and TVOCs and HEHO. So those are most of the things that you would encounter if you were laser cutting without an air purification system. And we can see when we're cutting through this wood that, you know, it's cleaning pretty much everything out of the air. So that's really quite awesome, and I really appreciate xTool sending this out. So special thanks to them, and I'll leave some links in the description down below. And so after cutting out all those pieces, we ended up with this nice stack of somewhat charred wood, and that charring is because it's a 40-watt module and we're cutting through 12mm thick plywood. It's pretty difficult to do that, and you know, it doesn't matter too much because I'm going for a really raw look where I want to sand it down just enough so some of the charring is still there, and then put a bunch of lacquer over it. But we have these rods which are 4mm, and the first thing I put on there was this 3D print, and this 3D print holds a little rubber band in place, and that holds the Vera ratcheting screwdriver in place as well. And after inputting all of those wooden components onto these tubes as well, we can put some glue between each of the layers, and I put some different glue between the plastic part and the wooden component because I wasn't entirely sure if the wood glue would attach to that either. After this, I put a bunch of glue clamps on there and let it dry out throughout the night, and came back the next morning. It was all held in place really nice and solid. I had to saw off those metal rods and sand it down quite heavily. That brings us to the last part of the process, which is the 3D printing. So that's a really simple part of the process. You know, you just drag in the STL, press slice, and you might want to adjust a couple settings if you want to enable supports or not. Maybe you want to enable fuzzy skin, which might be nice as well. In my case, I usually just leave everything on standard, and especially with Bambu Lab printers, most of the time that works out perfectly, and the print quality is really quite high on these machines. That main bit holder has a couple of 10mm magnets in there, which keeps the bits in place, and also 3D printed this little shell for the inside of where the screwdriver falls in place so that all of the charring on the wood doesn't, you know, rub off on the screwdriver itself, and that makes it slide in a little bit easier as well. I used some glue that I used in the beginning of the project as well to hold everything in place, and in the end it turned out into, you know, a simple but interesting little toolkit, and hopefully visually it'll be easy to find. So I think it'll be really interesting to do a video like this every single year and then see how the tool selection changed over the years, right? I mean, there's some standard stuff like drills and that kind of thing that I didn't showcase in this video, but you know, those really high-end tools, I'm really curious if one day we might be going to a CNC machine or, you know, welding and that kind of stuff. Yeah, I hope you enjoyed the video. I hope it gave you some inspiration for your own projects, gave you some insight into the behind the scenes of the channel as well, how all of this stuff kind of works together and links together, and hopefully see you in the next one.